Hello everyone, welcome to this channel. If you're new here, my name is Muhammad Hasan. Let's begin our sixth part of the video series. Today, firstly I'll go through a numerical problem based on mirror formula. The concept has been beautifully explained in my earlier video. If you haven't checked that video, then you can watch that video by clicking the icon in the upper right corner or by clicking the link in the description below. Then I will finish up the concept of magnification related to spherical mirror. Next I will solve some numerical to solidify the concept of magnification as well as the mirror formula, and finally I will explain you the concept of combination of mirrors with the help of numerical. So we have a lot to cover today. So without any further delay, let's roll the intro. Okay, today we'll be starting this video with a question based on mirror formula, and I have already discussed the concept of mirror formula in my previous video. If you haven't checked that video, then please do check that video by clicking the link in the upper right corner, and I'll also leave a link in the description below. If you haven't checked that, then please check that, otherwise it will be difficult for you to understand this question. Okay, so let's look into this question. The question says an object is placed at a distance of 40 cm from a concave mirror of focal length 15 cm. If the object is displaced through a distance of 20 cm towards the mirror, the displacement of the image will be. So very simple, you need to find out the displacement of image. Okay, this was asked in the year 2018 NEET. So let's see what's given. It says object is placed at a distance of 40 cm. So the object is U is minus 40 cm. We know it's a concave mirror. So the object, we have learned the sign convention. So the incident ray is in this direction, it will be taken as positive, and this direction will be taken as negative. If the object is here, then we need to go from pole towards this side, so it will be minus 40 cm. I hope this is clear. So U is equal to minus 40 cm, and the focal length is 15 cm. It says, so focal length, we know for concave mirror the focal length is always negative, so minus 15 cm. So these are the things given, and we need to find out the displacement of the image. So for that we need to find out the initial and the final position of the image. So let's see, this is the initial VI, initial position of the image formed in the first stage. It will be, directly we can say that V will be UF divided by U minus F. Okay, this is the formula that I've derived from the mirror formula. The mirror formula is 1 by F is equal to 1 by V plus 1 by U. If you derive this, the value of V, then you'll get this. Okay, so try to remember this formula for solving this kind of question very quickly. Okay, so V is equal to UF divided by U minus F. Now just put the value and you'll get it. So V initial will be U is minus 40 cm multiplied minus 15 cm divided by U is again minus 40 minus of minus 15 cm, because F is minus 15 cm. Just solve it. 40 into 15 will give us 600. Minus minus will become plus, and minus 40 plus of 15 will give us minus 25. So if we solve this, we will get minus 24 cm. Therefore, we are getting that if this is the concave mirror, then the first image will be somewhere here at a distance of minus 24 cm. Okay, now the question says that if the object is displaced through a distance of 20 cm towards the mirror. Okay, if it is displaced towards the mirror by 20 cm, therefore U becomes now minus 20 cm. Okay, focal length will not change, it is constant 15 cm. So V final, the final position of the image will be, again we'll be using the formula UF divided by U minus F. So U is minus 20 multiplied minus 15 divided by minus 20 minus of minus 15. Okay, so if we solve this, then minus 20 multiplied minus 15 will give us 300 divided by minus 20 minus of minus 15 will give us minus 5. So we got, if we solve this, we'll get minus 60 cm. Okay, so the image will be somewhere here. Okay, this is minus 60. So by how much has the image displaced? So very simple, the displacement can be found out like this. Displacement is equal to minus 60 minus of minus 24 will give us minus 36 centimeter. Now minus sign signifies that it is moving away from the mirror in the opposite direction, okay, because this direction is taken as positive for concave mirror and this is taken as negative. So we can directly say that the answer will be 36 centimeter away from the mirror. See how quickly we can solve this. Just remember this formula, that V is equal to UF divided by U minus F. Okay, let me give you the other variations so that it's easy for you. So we got V is equal to UF divided by U minus F. Similarly, we can say that U is equal to VF. Just replace the U with V. V minus F. Simple as that. And you can also say F is equal to UV divided by U plus V. So these are the variations, okay, so that you can solve the questions very quickly without taking LCM and then cross multiplying and then obtaining this result. Rather, you can use directly and solve the question and move forward. Okay, this is how you need to solve this kind of question. If this is clear, then I can guarantee that you can solve any questions if it is asked from this portion, like mirror formula in NEET. You can easily solve those questions and mark the right answer. So I hope the concept is clear. Now let's move on to our next concept. Okay, now we'll be looking into magnification. Okay, we have gone through the concept of magnification earlier, but a little bit of concept is still left, so we'll be discussing that and wrap off the concept of magnification here. So magnification, as you can see, is given by small m is equal to height of image divided by height of object. That is, we are comparing the height of image to the height of object, whether the image is getting bigger or smaller. That's what magnification actually is. And we have also discussed the sign convention. So let's see. The height above the principal axis is taken as positive. Suppose our image is formed in this direction. Okay, then we'll be taking the height to be positive. And if the image is formed in this direction, like inverted, then we'll be taking it as negative. So height below principal axis is taken as negative. So we can say that is inverted. If it is positive, then we can say that it is erect. So from there we say that m is equal to hi by ho, that is height of image divided by height of object, which is equal to minus of v by u. This is image distance and this is object distance. Okay, and we know that we measure this quantity from the pole. Now we haven't gone through this concept that m is equal to minus v by u. How we got this concept? Let's analyze that. Okay, here. So this is the concept that's still left. So let's see. Now in order to understand this, let's look into this ray diagram. Okay, suppose this is the object. Let me mark this. This is the height of the object and this is actually the height of the image formed. And we know that since the object is beyond center of curvature, therefore the image will be formed between center of curvature and focus, as you can see it here. Okay, this concept is clear. Now let's see. Now we need two rays in order to get the intersection point. So this is the first ray. It is going parallel to the principal axis, as you can see, and after reflection it will go through focus. So this is clear. The second ray is in pink color. It is going and hitting the principal axis at certain angle, suppose theta. Then according to our rule, it should reflect back at an angle theta to the principal axis. We have learned this rule that when a ray comes and hit the pole, okay, at certain angle theta, then it will get reflected at an angle theta with respect to principal axis. Okay, this was already discussed. This is the concept that we have used here. We got two triangles. One is in yellow color, as you can see this one. Another is in green color. So let's see the triangle ABP, that is the triangle in yellow color, and triangle A dash, B dash and P, that is in green color, are similar triangle. Now we can prove that. We know what is similar triangle. Triangle in which all the three angles are equal, then that triangle is similar triangle. In order to prove that, the first point is angle BAP is equal to angle B dash A dash P is equal to 90 degree, as you can see in the diagram. Second point is angle BPA is equal to angle B dash PA dash. You can pause the video and analyze that. Okay, so it will be equal. From the ray diagram you can see that both are theta, okay, according to this law. The third is very easy. If these two angles are equal, then the third angle has to be equal. So from this we can prove that these two triangles are actually similar. Therefore, from the property of similar triangle, we can say that A dash B dash divided by AB is equal to A dash P divided by AP. Now let's analyze A dash B dash. If you look into the diagram, then that is nothing but height of the image, and AB is nothing but height of the object, is equal to A dash P. If you look into the diagram again, A dash P is nothing but V, and AP is u, that is the object distance from the pole. Now I have missed out something. See, if you look into a dash b dash, then it is moving in the downward direction, that is the image that is formed is actually inverted, therefore we need a negative sign here, isn't it? So we can directly say that m, which is nothing but hi by ho, okay, and from this concept we found out that hi by ho is equal to, we took the negative sign this side, that is towards the right side, then it will be minus v by u. Therefore, comparing this and this equation, we can say that magnification is given by hi by ho, and it's also minus v by u. Okay, so this is the formula for magnification. This formula was already derived earlier. This is the formula that you need to remember. Okay, this is followed for both concave as well as convex. Okay, now you need to remember one thing, that this v and u will have values with the sign. So you need to put these values with proper sign. Okay, proper sign. So accordingly, if it is negative, then you need to put negative. It is positive, you need to put positive. It depends on the situation. Okay, now if this is clear, now let's move on to the concluding part of this part, that is the conclusion of magnification. Now we can say that if magnification is positive, that is, we can say that the object formed is erect, because if m is positive, that means hi by ho, this has to be positive, and this is obviously positive. Okay, therefore we can say that the image formed is actually erect, and we know erect object is always virtual. So simple as that. So whenever magnification is positive, you should remember that the image is erect, and if it is erect, it has to be virtual. Now coming to a second point, if magnification is negative, that means we know that this hi by ho is always positive. Okay, then hi has to be negative. If this is negative, that is the image height is negative, that means it is actually inverted, isn't it? If it is inverted, then we know inverted image is always given by real image. Okay, so if it is inverted, then the image has to be real. So these are the connections that you need to remember, and it's very important. Now let's see, if magnification, mod of magnification is greater than 1, it's simple, image is magnified. If mod of m is less than 1, very simple, again image is diminished. And if mod of m is equal to 1, then image is of same size. And I can say that if the object is at center of curvature, then the image is also at the center of curvature, and you have seen this in my previous video. So this is all about magnification, and if you understood all these concepts, then you're good to go. Now let's look into some of the numerical problems in order to solidify the concept that we have learned. So let's move on. Okay, now let's look into this question. This is a very important question and a conceptual question. So let's see. It says a concave mirror has radius of curvature 24 centimeter. How far is the object placed? If we get an image, the first question is virtual and 3 times the size of object. Okay, and the second is if the image is real and 3 times the size of object. So how far is the object placed? This is the question. Okay, simple. Now let's see. Now r is given to be 24 centimeter. So directly we can say that focal length is r by 2, or we can say that it is 12 centimeter. So this is done. Now we know that there is a relationship between f, u and v, and that is mirror formula. So ultimately we have to use that formula. But before that, you need to understand, it says the image formed is virtual and 3 times the size of object. That means the concept of magnification is needed here. So we know that magnification is positive when the image is virtual. Can you see how the concept is very important? So we can say 3 times the size of object means magnification is plus 3. Okay, that means the image is bigger than the object 3 times. Okay, so m is equal to plus 3. Now in order to apply mirror formula, that is 1 by f is equal to 1 by v plus 1 by u, you need to find the value of u and as well as v. Okay, you know this value. So how to find out? We know that m has a relation known as m is equal to minus v by u. Okay, so let's use that. So we can say minus v by u is equal to plus 3, or we can say v is equal to minus 3u. So that's done. Once this is clear, now why we found out v? Because we need to find the value of u. So we can use the value of v in terms of u here. Okay, it will be clear, don't worry. So let's now use the mirror formula, and I have showed you the trick of solving mirror formula very quickly earlier in this video. So let's see, we'll be using that. We need to find the object distance, that is object place, the value of u. So u is equal to, the direct formula is fv divided by v minus f. Now use it directly. Now we know the value of v from here. It is minus 3u, isn't it? And f is minus 12. Okay, because it is a concave mirror and focal length of concave mirror is negative. So these are small concepts that you need to remember. Otherwise you will mess up the whole thing and you'll get negative. Divided by v. Now the value of v is minus 3u, and minus of minus 12 will give you plus 12. Okay, if you solve this, then let's see how much we got. Now we can write that this is u is equal to this much. Now this u and u will get cancelled. Then we can say that if we solve this, we will get u is equal to 24. This side will be 24 and here it will be minus 3. Okay, so we'll ultimately get minus 8 centimeter. Simple as that. So we can say that the object, that is object distance, is 8 centimeter in front of the mirror. So if this is the mirror, concave mirror, and the focal length is 12 centimeter, so this is the focal length, 12 centimeter. So the object should be somewhat here. Okay, that is, you can say 8 centimeter in front of the mirror. And we know that when an object is placed between focus and pole, then we get virtual image, and this is satisfied here. So the object is placed in between focus and pole. So this is the first part of the question. Now let's look into the second part of the question. It says the image formed is real and 3 times the size of object. If the image is real, that means the image formed is actually inverted. We know real image is always inverted, so the magnification will be negative, isn't it? So we can say therefore m is equal to minus 3. In the earlier case m was plus 3 because it was virtual. Now m is minus 3 because it is real. Now from the formula of magnification, minus v by u is equal to minus 3. Minus minus got cancelled, so v is equal to 3u. Okay, in the earlier case we got v is equal to minus 3u. Simple as that. Now just use the mirror formula and the direct shortcut formula. Like you need to find the object distance, so you need to find u. So u is equal to vf divided by v minus f. This is how you need to solve things quickly. Okay, and this will come with practice. Okay, we can say that u is equal to, just put the value of v is equal to 3u. F remains constant, that it was minus 12, and v is again 3u, and this minus minus will become plus 12. Now if we solve this, then we will get u got cancelled, and if you solve this, then it will be turning out to be u is equal to minus 48 by 3, and it will be minus 16 centimeter. Okay, so minus 16 centimeter, that means if I draw it here, like this is the mirror and the focal length is, suppose this one is the focal length, that is minus 12. So the object is somewhat here. Okay, that is at a distance 16 centimeter in front of the mirror. I hope the concept is clear. And we know that whenever object is placed beyond focus, then it always produces real image. Okay, it always produces real image, and the image is inverted for concave mirror. And you can see that it's satisfying the behavior. Okay, so this is all about the concept related to magnification and mirror formula. Okay, I hope the concept is clear. We have joined both this concept in this single question. So this is very important. Now let's look into another problem and we'll be wrapping up this concept. Now let's look into this question. This is super simple. If you understand the earlier question, then this is a piece of cake for you all. A concave mirror of focal length 10 centimeter. So focal length is 10 centimeter, is concave, therefore minus 10 centimeter. Simple. Produces an image which is 4 times the size of object. Find the object distance. See, m is positive 4. So we can write m is equal to plus 4. Now you need to find the object distance, that is basically you need to find u. Okay, so simple as that. We know that u is equal to vf. Just follow how I am doing it. v minus f. Okay, you know this formula, so you need to substitute the value of v here in terms of u, and you can do that by the magnification formula here. Minus v by u is actually 4 from the formula of magnification. Therefore, we can say that v is equal to actually minus 4u. Now just put this value here and you'll get it. Or we can say that u is equal to minus 4u and f is minus 10 divided by minus 4u plus 10. Minus minus becomes plus. Now if you solve this, then you're going to get that u will be equal to, this will go this side, cross multiplication. Okay, u will be minus 30 by 4. Therefore we can say that this is nothing but 30 divided by 4 is minus 7.5. okay, so minus 7.5 centimeter. Therefore you can see that actually minus means in front of the mirror in terms of concave mirror. The magnification here is plus 4, which signifies that the image is actually virtual. That means the object has to be between focus and pole. This is pole. Okay, and we can see that yes, it is actually following that rule, and the object is placed somewhere here at minus 7.5 centimeter, that is before the focus. Okay, or you can say between focus and pole, and yes, it is satisfying, and therefore you can see that the image formed is actually virtual. I hope the concept is clear. This is how you need to solve this kind of question. Okay, simple as that. Now let's move on. Okay, this is the final concept of the video, and I will explain this concept and wrap up the video. Okay, the concept that we'll be discussing is combination of mirror. We'll understand this concept by solving some questions, and I think it will be clear. Okay, so let's look into our first problem. Now combination of mirror actually means that we'll be using like two mirror, and we will place object in between the two mirror, and we'll find the final image after certain number of reflection. Okay, so where will be the image formed? So this is all about combination of mirror. So let's see and check the question. Find the final image after two reflections if the first reflection occurs at M1. So the first reflection is occurring at mirror 1. As you can see, there are two mirrors. So the first reflection is assumed to be at M1, and it says after two reflection where will be the image formed. So I've drawn the diagram, and it says that there are two mirrors, that is a concave mirror having focal length of 20 centimeter and a plane mirror. We know the focal length of plane mirror is infinity, so it's not given. So there are two mirrors, M1 and M2. So how to solve this kind of question? So let's see. Now the object is placed, this is the object actually, this point is the object. It is placed 3 centimeter in front of the concave mirror and 2 centimeter in front of the plane mirror. So since M1 is taken as the first point of reflection, therefore we'll consider it first. So where will be the image formed if we use mirror 1 as the first point of reflection? And since this is a spherical mirror, we will be using mirror formula, and we know the direct formula for finding the image distance in case of spherical mirror. So let's see, we will be using it directly. We know that V is equal to UF divided by U minus F. This is the formula we have learned to solve things very quickly. U, if you look into U means object distance in front of the mirror. Now this is the direction of incident ray, so this direction will be taken as positive and this direction will be taken as negative. Okay, now the object distance will be taken from pole towards this direction to this point. Okay, it is minus 30 centimeters, so U is nothing but minus 30. Focal length also, we can see that focal length is from here to here, it is 20 centimeters, so we'll be writing minus 20 centimeter here, divided by U is minus 30, and minus of minus 20 will be plus 20 here. Now if you solve this, we'll be getting 600, minus minus becomes plus, and minus 30 plus 20 will be minus 10, and we will be getting this as minus 60 centimeter. Minus 60 centimeter means that the image will be formed 60 centimeter in front of the mirror. So let's see, if this is 30 and this is 20, we got 50 centimeter here, so more 10 centimeter behind this, so we can say this total is actually 60 centimeter, or we can say 10 centimeter behind mirror 2. So you got the image formed by the spherical mirror to be here, that is 10 centimeter behind the mirror 2 or 60 centimeter in front of mirror 1. Once this is clear, now the next concept that you need to understand is this image will act as virtual object for mirror 2. Why? Why virtual? Because see, the object is behind the mirror. Since the image is formed behind the mirror M2, therefore we will say that this image will actually act as virtual object for M2. Okay, so let's see. If this is 10 centimeter behind, then we know according to the concept of plane mirror, if this is the plane mirror and we keep any object, suppose x centimeter in front of the mirror, then we will get image x centimeter behind the mirror. So it's simple. So if the virtual object is 10 centimeter behind the mirror, then we will get the image of this virtual object somewhere 10 centimeter in front of the mirror. So this should be 10 centimeter. Okay, so this is the final, we can say this is the final image. Now let's understand how it is happening. Now what happened here actually is the rays from the real object, this is the real object, okay, went from this direction and hit the spherical mirror. After hitting, what it did is the direction will be in this direction. It goes and hit mirror M2 here. Okay, then after that this reflects back to this point. If you look into the second ray, this is the first ray, this is the second ray. The rays goes from here to hit the mirror, spherical mirror. After hitting, it goes in this direction and hit the mirror M2, that is the plane mirror here. After that, after reflection, it goes and meet here to form the final image. Okay, this is the real thing that is happening. But in order to make the solution easier, what we did, we found out this point and we considered this as virtual object for M2, and we easily found out the final image. Okay, this is how you need to find out. I hope the concept is clear. Now let me explain it in easier term and things will be much more clear. Okay, so let's write down the steps. See, it's very easy. The steps are, firstly what you need to do is find the image formed by the mirror M1. If it is a spherical mirror, then use mirror formula directly that we have used, and we need to use this formula V because we need to find the position of image formed by the first mirror. So V is equal to UF divided by U minus F, and this formula should be used with proper sign. Now for the second reflection, what we will do, the image that we got will act as a virtual object for the second mirror and then find the final image. Now in the first question, what I've done is I have taken two mirrors, one is spherical, one is plane. Okay, so for the first mirror I used mirror formula and the second one is plane mirror. So there's no such formula, it's simple, use this technique to get the result. But if I use two mirror where both mirror are spherical, then I have to use here for the first mirror this mirror formula, and for the second mirror I need to again use mirror formula. So I'll show you that by one example. So let's move into that. Okay, the second question says find the final image after two reflections, assuming the first reflection occur at M1. So this is our first point of reflection, or this is the first mirror of reflection. Okay, this is M1 and this is M2. So the concept is similar again. In the earlier case I took one spherical mirror, one plane mirror, but here I have taken both spherical mirror. So let's see, the first mirror is a convex mirror and the second mirror is a concave mirror. So how to solve? Now I have already given you a step, like there is a two process step. So let's analyze that first. The first step says that firstly what you need to do is find the image formed by the first mirror M1. Okay, if it is a spherical mirror, use mirror formula directly. That is, the formula is V is equal to UF divided by U minus F. And we can see in the second case, yes, the first mirror is a spherical mirror. So we'll be using this mirror formula to find the value of V. Now, once we get the value of V, we will treat that image formed by the first mirror as a virtual object. I have already labeled that with green color. So that will act as a virtual object. And then we will be using a mirror formula for the second case, if the second mirror is a spherical mirror. And in the first case, it was a plane mirror, so we haven't used that. But in our second case, we'll be using again mirror formula to find out the image distance. Okay, so let's see. Okay, now what we'll do, this is our object O. Okay, 20 centimeter in front of mirror 1, and 30 centimeter in front of mirror 2. Now we'll be using this formula V. V is equal to UF divided by U minus F. Now U, we know the incident ray, this will be our incident ray in this direction. Okay, so this direction will be taken as positive, direction of incident ray, and this direction will be taken as negative. Therefore U, as we can see, U, we need to measure things from the pole, so we need to go in this direction. Okay, so we will take that it is opposite to the direction of incident ray, therefore will be negative. So minus 20, and F, again we can see F is 20 centimeter, and we know that for convex mirror F is always positive because the F will be in this direction. Okay, this is focus, so we need to measure it from the pole, so we need to go in this direction, therefore it is positive. So you can say that focal length will be positive, that is 20 centimeter. Divided by, again U will be minus 20, minus of plus 20 is minus 20, so this is minus 400 divided by minus 40. We can just calculate this to be 10 centimeter. So you can see that it is 10 centimeter but behind the mirror, so in this direction, because it is positive. So the image will be formed somewhat here, 10 centimeter, that is, this is our 10 centimeter. Okay, so this is our image. Now this image will act as virtual, understand the concept, virtual object for mirror 2. Now if this is the virtual object and the second mirror is a spherical mirror, then in order to find the image location we need to use mirror formula. So again we'll be using mirror formula to find out V, okay, for M2. So V will be again UF divided by U minus F. Now U is the virtual object here. Okay, if we analyze the ray diagram now, then you'll see that the rays will be coming like this. So this is the thing, this is the ray that is after reflection from mirror 1, and this is the ray after reflection from mirror 2. Okay, because we know convex mirror is a diverging mirror, it will diverge the rays and it will meet, the object will be found behind the mirror for convex because the point of intersection is behind the mirror. Okay, once it goes this side for mirror M2, this is the direction of incident ray, therefore this direction will be taken as positive for mirror M2 and this direction will be taken as negative, opposite to incident ray. Once this is clear, now let's find the value of U. Okay, U is, if you analyze, the virtual object is at a distance that is 30 plus 20 plus 10, that is 60 centimeter, isn't it? But in the opposite direction, because this is the pole and we need to move in this direction to find the value of U. So it is minus 60. Now F for concave mirror is always negative, I've explained this, so F will be minus 10 as it is given here, divided by minus 60, minus of minus 10 will be plus 10, and if we solve this we will get 600 divided by minus 50, and if we just cancel out you will get minus 12 centimeter. So minus 12 centimeter means in front of mirror M2, because this direction is taken as negative, so it will be somewhat here like minus 12 centimeter. Okay, so ultimately the rays comes and meet here. Okay, this is the point of intersection. This is the ray diagram. I hope the concept is clear how we are solving this. Again, I'll repeat. If you look at the steps, you just need to remember these two steps. Firstly, you need to find the image found by the first mirror. Okay, by using mirror formula if it is a spherical mirror, and use this formula. Secondly, once you got the value of V, that is the image location, then use that image as a virtual object for the second mirror and then find the final image. If the second mirror is a spherical mirror, then you need to use mirror formula. If it is a plane mirror, then it is simple. Okay, you don't need to use mirror formula. I hope the concept is clear for combination of mirror. This is all about combination mirror. If you understood these concepts, then you're good to go. Okay, so this is all about this video. I hope the concept is clear. If you enjoyed this video, then please give it a thumbs up, and if you haven't subscribed to this channel, then please consider doing so. Till next time, enjoy your studies and build your concept, and I will catch you all in my next video. Bye bye.